Starting in 2021, the three major Japanese car companies Toyota, Honda, and Nissan have successively released their 2030 strategies. These strategies all take the research and development of solid-state batteries as one of their key strategies. In 5 years at most, the three car companies need to complete the trial production, mass production, and application of all solid-state batteries, and the pace is very tight. In fact, Japanese car companies that have lost their momentum in the era of fuel vehicles are extremely low-key in the current global electric vehicle market. But the setting of the solid-state battery timetable shows the attitude of the Japanese. The dominant leadership position lost by liquid lithium battery electric vehicles will be regained in the competition of the next generation of electric vehicles. So, is there a chance for Japanese car companies to make a comeback in the pure electric vehicle market with solid-state batteries? Honestly, I have to say that it will be more difficult. On the one hand, solid-state battery technology is not only being developed by Japanese companies, but also by various companies and battery suppliers around the world. Secondly, the first-mover advantage of pure electric vehicles is very important. Tesla has been selling well because of the first-mover advantage. However, Japanese car companies, such as Toyota, are currently focusing on hybrid vehicles, and they didn't perform well in the field of pure electric vehicles. Then, how can they reverse the situation with a solid-state battery? I'll make my point with more concrete data in today's video. At the same time, as an upgraded version of lithium batteries, solid-state batteries are superior to liquid lithium batteries in terms of energy density, charging rate, safety, cycle life, and cell thermal management, and are regarded as the next-generation battery technology. Therefore, Japanese car companies that are late to the electric new energy vehicle market are accelerating the deployment of solid-state batteries. So, how should China, which is currently leading the overall new energy vehicle market, respond? Your vision is your world. Welcome to Auto Age. Now you are on the journey to look back at every change in the car, witness every surge in speed, and explore the mystery behind the car. Before we started today's video, please subscribe to the channel and turn on the notification bell. Okay, let's get started. First, let's take a look. What are the advantages and disadvantages of all solid-state batteries? All solid-state batteries are products made of solid rather than liquid electrolytes that serve as channels for ions to move between the anode and cathode. It has a structure without electrolytes and separators, so it has the advantage of strong impact, while enabling the placement of materials with higher energy densities. In theory, all solid-state batteries can increase the driving range of electric vehicles and reduce the risk of fire in the event of a collision, so they have been attracting attention as a next-generation battery to replace the current lithium-ion battery. While solid-state batteries have great advantages, they also have significant disadvantages. Their internal resistance is higher than that of lithium-ion batteries that use liquid electrolytes. In all solid-state batteries, since the electrolyte is solid, the mobility of ions and the adhesion of electrodes to the electrolyte must be poor. Due to these characteristics, many experts have questioned the efficiency and instantaneous output of all solid-state batteries. Especially with the recent increase in the popularity of electric vehicles, the competition in the field of high-performance electric vehicles has intensified, and some people have questioned the competitiveness of all solid-state batteries in the high-end electric vehicle market. Second, solid-state batteries are not only being developed in Japan. Because solid-state batteries have better safety, so not only Japanese companies are now developing them. Taking Hyundai Motor Group as an example, the mass production time of electric vehicles equipped with all solid-state batteries is scheduled for 2030. Hyundai Motor announced its development roadmap through a conference call in April 2021, saying that after trial production of electric vehicles equipped with all solid-state batteries in 2025, it will be ready for mass production in 2027, and focus on full scale around 2030. Toyota of Japan, which has the most relevant patents, announced that it plans to mass-produce electric vehicles equipped with all-solid-state batteries by 2025, and also released a test drive video of all-solid-state battery electric vehicles in September 2021. But the company has since taken a step back, saying it will launch an all-solid-state battery hybrid in 2025 and a pure electric vehicle in the late 2020s. Major automakers such as Mercedes-Benz, BMW, Ford and Honda predict that all-solid-state battery electric vehicles will be mass-produced around 2030. In addition, Samsung SDI started building a pilot production line for all-solid-state batteries in South Korea in March this year, and is expected to be fully mass-produced in 2027. SK On plans to partner with US Solid Power and others to deliver all-solid-state battery prototypes to Ford and BMW by the end of this year, and then accelerate commercialization. Moreover, CATL, the world's largest battery manufacturer, expects that all solid-state batteries will be mass-produced in 2025, which also shows great strength. However, it is worth noting that among the top 10 all-solid-state battery patents, there are 6 Japanese companies, 4 Korean companies, and no Chinese companies on the list. So, what is China's current plan? In essence, battery charging and discharging is the process of lithium-ion migration between the positive and negative electrodes through the electrolyte. As the viscosity of the liquid electrolyte increases in a low-temperature environment, the charge and discharge capacity decreases, resulting in a reduction in the range. Its unstable characteristics also bury the hidden danger of spontaneous combustion of the battery, but the solid electrolyte not only avoids the above problems, but also improves the energy density, cycle life, and charging rate of the battery, reducing the need for thermal management of the battery. The solid state in solid-state batteries refers to the form of the electrolyte. According to the proportion of electrolyte, it can be divided into semi-solid battery, with electrolyte content less than 10%, solid-state battery, with electrolyte content less than 5%, and all-solid-state battery, without any liquid electrolyte. Solid electrolytes are divided into 3 technical routes: polymer electrolytes, oxide electrolytes, and sulfide electrolytes, and the ionic conductivity of the 3 is increasing. High ionic conductivity means lower resistance and easier fast charging, but the development difficulty of the 3 is also progressive. Therefore, sulfide is most suitable for electric vehicles, but it is the most difficult to develop. Europe and China tend to choose polymer electrolytes and oxide electrolytes that are relatively less difficult to develop and easier to commercialize. But Japan and South Korea chose the most difficult part, sulfide electrolytes. In addition to the choice of electrolyte, countries also have differences in whether to directly challenge all solid-state batteries. Among them, Japanese manufacturers choose all solid-state batteries, and Chinese manufacturers are more aimed at the semi-solid-state battery market. However, in my opinion, the advantages of all solid-state batteries have not been fully verified at present, and their industrial prospects may be similar to hydrogen fuel cells. It is very unlikely to replace liquid power batteries on a large scale when applied in specific scenarios. Perhaps the time when solid-state batteries are really put into large-scale commercial applications is between 2025 and 2030. Therefore, before the all-solid-state technology is immature, Chinese manufacturers have chosen a compromise solution and implemented semi-solid-state batteries. So, in this fierce competition, who do you prefer? Okay, that's all for today. Please put your comments below, and share your insightful ideas with other people. Do you want to learn about more auto stories? Please keep following our channel and like our videos. Thank you so much for your continuous support. Your precious time with us is highly appreciated. See you.